Everybody, my name is Eli. Just going to talk RecyclerViews and Epoxy tonight. Has anyone heard of Epoxy? Yeah? I just coincidentally released a blog post that I've been working on for a few months and finally came out today. Good timing for this talk. And yeah, you guys are all familiar with RecyclerView pretty much, right? You guys teach in this class.
Yep.
What week are you in right now?
They're in week 7.
Okay, so pretty far.
So,
You've had lots of time to play with RecyclerView. It's a fun library. So I'm going to just go through talk a little bit about RecyclerView. I won't spend much time on that because you guys are already over there. We'll go into adapters, how Epoxy helps clean up RecyclerView adapters, and how we can use Epoxy to build in our architecture. Okay, so basic RecyclerView overview. It replaces the old list view. That was the original way to display a scrolling list of items in Android. And RecyclerView is just a lot better in many ways because you can do things easily such as item animations, decorations, you can do swiping, any sort of touch inputs. If you want flexible layouts like grids or staggered grids, there's custom layout managers you can write. And none of that was really possible in a list view, or if you did do it in a list view, it was really complicated and hacky. So RecyclerView for the past year or two has been gaining a lot of momentum. Everyone really uses it now, and it's pretty great. On the other hand, all of this power and flexibility comes at the cost of kind of complexity, boilerplates, and just kind of confusion knowing what's going on and getting started. So to begin with, list view had a built-in header and footer. Those are pretty common things. Often you want to show maybe a title at the top, loading indicator at the bottom, or some other footer, and you could add those directly in a list view. RecyclerView got rid of that API. You have to do that manually. List view had just a general notify call you. Finish building. List view, you just say data change and it would update. RecyclerView introduced the notion of updating certain ranges or items. You can say item at position 5 changed, or item range changed, or item removed, item updated. And that's really powerful because instead of redrawing the whole RecyclerView in every item, it can only redraw a specific item or what changed. However, you need to figure out what changed and tell it. It's only as good as how you use it. And when you have many items, knowing what changed can be tricky. And we'll talk more about that later. And then other complications with the RecyclerView is mostly the boilerplate of setting up, creating view holders, binding them, dealing with item types, item IDs. And that especially gets tricky when you have more than one item type in any sort of more advanced list, when you're showing multiple view types, headers, footers, all those sorts of things that you encounter in real apps instead of just basic examples. So let's take a look at what a simple RecyclerView looks like. This isn't too basic. It's 3 item types, but it's still fairly simple compared to what we use in practice. So this is just kind of what a simple photo display might look like, with a header at the top that maybe says your photos and X amount of photos that we load from the network, plus a loading indicator shown at the bottom whenever we paginate through. So this is kind of everything you need to do to set up your RecyclerView adapter. You have get item count, item types because we have multiple view types. You have to create the view holders, bind view holders, and a little bit tricky because sometimes you're showing the loader, sometimes you're not. You're always showing the header at least, but you need to know what position that's in. And you end up doing all this kind of funky custom logic, checking positions. You're doing like case statements to check view types. Sometimes you're doing instance of to check whether you have a view holder that's an instance of your photo view holder or your header view holder. And you can see that this easily gets very complicated and messy. And even in the set data method I have there, I'm just doing a basic notify data set change. If we really wanted to do this well, we would check if the loading state changed, notify that. We would have to check if the photos changed at all, notify what photos changed. And that adds extra complexity. I didn't even include the method to give item IDs here. And are you familiar with stable IDs in RecyclerViews? Anybody?
What?
Stable IDs. This notion of each ID in a RecyclerView has each item in a RecyclerView has a unique ID that no other item will share. and you indicate that to the RecyclerView by you say set stable IDs is true, and what that gives you is more efficient item updates, since it knows that for a certain item, if the ID is the same, then it's the same view, and it can reuse that. And then it can also do animations. So if you've noticed with RecyclerView, sometimes it can be intelligent about item changes and do animations for you. So if you insert items or remove them, it'll automatically animate those changes for you. And it can do that because items have IDs associated with them, and if it knows that ID disappeared or was added, that is a new item. But you have to be able to tell it what those IDs are and when they change. So this is the complicated way to do things. And like I said, that's still a relatively simplistic approach. Airbnb and many other apps have much more complicated lists, RecyclerViews. Facebook is a maybe prime example of one of the most complicated views. They have so many view types in their feed, and they've written a lot of custom libraries to deal with loading those feed items efficiently. We don't have quite so many types as them, but we still have 8 or so. This is our new search RecyclerView. It's the main view in the app when you open it up. And what we have here is results with nested carousels. So each item in the RecyclerView, we have a section header here, homes, and then we show a nested horizontal scrolling RecyclerView of those items, and we go on to feature destinations. We show trips and places. We show a pagination loader. Sometimes we show dividers. In certain countries, we have to show pricing disclaimers about total price or taxes. Then there's error messages when maybe there's a network error. We also want to be able to throw in call-outs like saying, hey, add a filter for pools because we know you're going to San Diego and that's a popular filter, and we can do kind of suggestions on how to do better searches. And all of these, to do smoothly, we want to insert them inline in this view instead of doing a popover or something. It's much better user experience to insert it into the RecyclerView with all the other items. And you quickly accumulate a bunch of view types. The previous example I showed was 3. This is maybe 8. And they all have logic about they're only shown in sometimes, not others. They all have different view holders you have to bind to. It gets complex fast. On top of that, it's not just a write it once and you're done thing. Our search page changes constantly, and most apps are being developed and iterated on all the time. You have new features being added, experiments being run where you're only showing a certain view type if that experiment is enabled. Designs change and designs are updated. You need to change certain views. And any sort of complex RecyclerView with all these view types, it's already so complex, and if you're changing it constantly, you obviously introduce a large chance of regressions, causing bugs. Even if you're able to add these features without introducing bugs, you're just spending a lot of time testing and maintaining because it's so hard to modify code because it's complex. So we encountered this for a long time. We struggled with it. We rewrote our search page again about 10 months ago, and we were rewriting large parts of the app. Almost every screen got rewritten, and we were using a lot of RecyclerViews. And I noticed the same pattern of item IDs, item types, binding view holders, and figured there's got to be a better way. And there are quite a few libraries out there for simplifying RecyclerViews, some similar ideas like Epoxy, but we took it one step further, and I'll get into what we do that I haven't seen any other libraries do. So basically the idea with Epoxy is use composition and delegation in the adapter. Instead of having the adapter know everything, you specify all your item types, your item ID, your view type, your binding. That's delegated to a separate, we call them Epoxy models. And the adapter just knows what models you're showing, and it delegates all the other work into the model. And it does a lot of boilerplate reduction for us that I can show you. So that's the high-level idea of Epoxy, just simplify this RecyclerView complexity. So let's take a look at what that actually looks like. Here is the subclass of Epoxy adapter, which is the library we provide. And this is doing pretty much the same thing that you saw in the RecyclerView adapter. It's showing a header with a certain amount of photos and a footer if needed. This is actually doing more than the other example, because it's also handling item IDs. You're getting stable IDs, and you're getting item notifications done for you. Notice the call at the bottom, notify models change. That's an epoxy method that will look at all the items that you had before and the new set of items, and it calculates a diff of what changed, what was added, removed, updated, and tells the RecyclerView exactly what changed. And this is obviously much clearer to read. It's shorter, way less lines of code for one thing. Also easier to understand what's going on. Much less room for introducing bugs because it's easy to read and clear. Pretty much better in every way. And you still have to write models for each item. I can show what those look like, but this is obviously a step up. I'm going to dive into some kind of how Epoxy does this and other features it gets you that RecyclerView doesn't really offer. So the Epoxy model basically handles item ID, the type, it gives you a layout resource and we get the item type from that. The model handles all the binding of the view, setting images, titles, text, and also it handles cleanup. So if you're setting images on a view in your RecyclerView and you scroll it off screen, we can release that bitmap so it doesn't keep memory while it's off screen. So these kind of optimizations we can do. Another thing is if you're using a grid, that adds extra complexity. I haven't shown in that example, but you have to define span size for each item. So your item needs to know how many columns it takes up in the grid. One extra thing to define, and the models help with that really easily. Another little thing we've run into is needing to save state. I showed up here we have these carousels. We have our homes and our trips and destinations. And if you're swiping through a carousel, maybe you switch tabs, come back, scroll down, scroll back to the top, you expect that carousel to be in the same position you left it at. But RecyclerView doesn't actually give you any way to save a view state. And we had to write that custom, and we were able to kind of pull it out into Epoxy and let you generalize it to save the state of any view in your recycler adapter. So this delegation approach is really powerful, and everything ends up cleaner. You notice the adapter only really has one method, set data, and this method is idempotent, so you can call it as many times as you want. Maybe you're loading data from your database, you're loading it from a network cache, then you get an updated network response, and you might have data coming from a couple different places like this, and you don't have to worry about, oh, I've already set this page, I loaded more photos, I need to do set more photos instead of add original photos. You're not really dealing with state. You just have this one set of objects, you give it the adapter, and it has like very functional approach where it just takes an input and builds your output for you. It only notifies adapter changes if something's changed. If you call this set data method twice in a row with the same data, it's not going to notify any changes to the RecyclerView the second time, so nothing is redrawn. It's easy to read. You can look at this code, share it with people. You can have a bunch of people maintaining an adapter or adding to it, and it's pretty easy to tell what's going on. And this is all just basic engineering practices that let us build faster and iterate without having to deal with bugs and getting kind of mired in maintenance. So I've talked a lot about models. Here's what they actually look like. The base model is an epoxy model, and it defines a view. So for each model, we bind a view to it, and that view is what is actually shown in the recycler view. And we also have whatever data goes into that view. And our epoxy model takes the data and is kind of the adapter that takes the data and sets the appropriate fields on the view, kind of like a presenter. In a model view model approach, this would kind of be the view model. Slightly different. And you can see here the photo model defines everything the adapter needs to know about how to use this. It tells you what layout to use or get default layout, so it can inflate that layout resource to actually create the view. It has a way to set this photo in the constructor, so the photo object and you can see the ID is being set off the photo, and that's going to be the ID of this view. And then when we're actually binding and unbinding the image, we're just taking the URL off the photo and setting it on the image. So the photo is also a pretty straightforward class. Try to keep it simple. You can add obviously more data to it. In practice, you end up with possibly many fields on this photo model. But it still stays relatively simple compared to keeping everything.
You define the generic type as image view, but then you show a layout. What's inside that layout? Does it have to have only a view group and then an image view? Or?
Yeah, so there's this implicit agreement there. And everything needs to be inflated from XML. So that's just an XML file. And the agreement here is that whatever is inflated from that XML file needs to be the same view type as what the model is typed with. So it would be an image view.
So it's going to be just an image view, no view group.
Yeah. So this is a very simple example. You can make whatever custom view you want. Our common pattern is to make a custom view. We will extend something like relative layout, frame layout, linear layout. Make our more complex view. We'll do that for our listing cards or whatever view we need to show. And then we'll have that custom view and just set the data on it here. For simpler views, Epoxy also supports view holders. In the normal RecyclerView adapter, there's a concept of view holder, and that's holds the references to the text view, image view, whatever you have in your layout. And if you don't want to deal with making a custom view, you have a simpler data structure, or view structure. You can just use a view model, or sorry, view holder approach to it. That keeps things simple. Yeah, and you notice there's this @epoxy attribute annotation. I'll get into what that is later, but basically we have an annotation processor that helps us generate the methods we need to set this data and keep track of state without introducing boilerplate. Any questions so far about all these adapters?
Yeah. So in the project that we're doing now, I was working with RecyclerView, and I wanted every custom item to have a counter.
A counter.
Yeah. And now my problem was if something went off screen, but the counter, like I didn't have any reference to it because it wasn't there. It wasn't recycled yet.
Yeah.
And so would the stable IDs fix that? And does Epoxy have that?
So when it's off screen, you want to be able to reference it?
Yeah, I mean, let's say it starts it plays in something, or maybe I want to pause it for some reason, but it's off screen, so I can't tell the RecyclerView to hand it to me because it doesn't know its existence, right? Because it knows only simple RecyclerView knows only what's on screen, or one like with offset.
Yeah. That's not really something Epoxy can help with because RecyclerView's nature is to get rid of that view. So once it goes off screen, you can never really access it, and that's not what we try to solve. But that is a problem. We'll see that often with text views. Like we'll have a text input, and user might maybe there's a search bar at the top, and they input text and scroll it off, and you can't access that view anymore. So the approach we take, and there's a couple ways to do this. The general way is you have a listener, and anytime that your input is changed, so you have your counter anytime that's changed, from the view activates a listener and calls back into either the adapter or the fragment or the activity, and it updates the data. So the view doesn't really store the data, it doesn't really know what's going on, it just displays it. Whenever there's user input, it calls back into whatever interface it has and says counter incremented, counter decremented, whatever, and that data is then updated and stored elsewhere. And then when you want to find out the state of that view, you would just reference that data you have instead of going to the view.
And the stable IDs won't help because you said that.
Yeah, the stable IDs don't keep a view from being recycled.
But do I have a reference to a view once I have its ID?
You can get a reference to the view if it's on screen, but as soon as it goes off screen, it could, it's not in use. Like it could go anywhere. So. Yeah, unfortunately. So that's one downside to RecyclerViews is mostly the user input is much tougher to handle because you can't just reference a view whenever you want to.
I have a question.
Yeah.
I noticed that you have to instantiate the model with a photo object. But later on, you also have to bind that same attribute. I'm trying to understand the RecyclerView. You have multiple objects that are being swapped in and out. Like, how does that work?
Sure. So the All the adapter is doing is setting the model here. So that's the only thing. So we create a photo model with the data. And the bind method is called by the epoxy internals.
Got it.
Yeah.
So you actually have to, like when the RecyclerView, does it just keep reinstantiating the photo model?
So the photo model will be instantiated whenever you call set data.
Yeah.
So it'll clear the existing models, and we have this models list, which is just your declaration of what models to show, and it will take all the models you added to it. Whenever you notify changes, it'll look at the list of models, and then use that to build the view.
Okay.
And yeah, I can talk just a little bit about what it looks at. So basically, you add all your models to the list, you notify changes, and then it knows how many items are in the adapter because of the size of the models list. When it needs to get item types, we just use the layout as the type, because that's our ID, like the layout file is like a static unique ID because of how Android resources work. So that's a safe item type. The item ID is also stored in the base epoxy model and handled there for us automatically because we've set it and then we don't have to worry about it. When the onCreate viewholder method is done for us, what epoxy does is calls get default layout. It takes that layout resource, it inflates it, and it knows that you have an image view from that. So that created the view holder for us. And the onBind view holder just takes that image view and passes it into our bind method. So it hooks up all these things for us. And unbind the same way when we.
If you go back to your previous slide, notice though that, like, does that mean that you have to pass in the entire list of photos? Like, let's say you have 1,000 photos.
Yeah.
You actually have to instantiate 1,000 photo model objects?
Yeah. So yeah, that's one downside. If you're showing a lot of items, it's a little bit more memory. If you are showing 1,000 items in a RecyclerView though, you would have always needed to have those 1,000 photo objects instantiated.
Gotcha.
So basically the epoxy model, the photo model here is a wrapper around that data.
Got it.
It's a little bit extra overhead, but you can see it's basically all it's holding is a reference to your photo. So it's an extra just few bytes for each photo. That adds up, but then if you really don't want to hold that many things in memory, you need to have a different approach than just a normal RecyclerView, which gets more complicated. In our experience, we don't have to worry about that. We're loading most I've had to deal with maybe in a large messaging app is our messaging page is like 600 or so I've played with, and it still works fine, no problems. If you're dealing with thousands of items and many pages of data, you probably want to do something more custom. But for all use cases we deal with, it's not an issue. Right? Okay, let's talk a little bit more about stable IDs. You had already asked about it, so I explained a little bit about what we do here. But the stable ID is just a unique ID given to each model, and it should not be used or shared with any other model. And it just lets RecyclerView know that for this ID maps to a certain model in this view and data. And this allows us to save a view state. So my carousel, the home's carousel might have an ID of 3, and I save the scroll position of that carousel to that ID. When I scroll away and come back, I can restore that scroll state to the model at position 3. Also helps with diffing. I'm going to talk a little bit about diffing later, but it's not possible without item IDs because you can't associate state without having these stable IDs. And like I said before, also RecyclerView gives us default item animations if it knows what IDs are. And IDs can be a little bit tricky. Say we're loading data from the server, we have a photo object we loaded from our API. We can get an ID from that. The server can just tell us what its ID is. But then we have a header and a footer, and this header is just a text field. We have a loader indicator. Like that doesn't really map to an ID. And it's kind of like comparing apples and oranges. You have a photo ID and a header. Like what? It's not clear what the ID should be there. And we solve this by just using a negative counter. We start at -1 for models like the header and footer, and we assign -1 to the header and then -2 to the footer, and whatever model comes after, we just give it the next negative number. And since we're just decrementing throughout the whole app lifetime, we're never going to create the same ID. And it's a long, so we have trillions. If we do want to override it, like for the photo model, I overrode it with the photo ID. And that's an ID from a database. And those start at 1 and go up. They're, by convention, positive. And so we shouldn't have any conflicts with the negative ones that we generate. So that kind of solves the problem of how we handle IDs and stable IDs for views that don't traditionally have a ID that would go along with them. And so for a lot of views, that makes it really easy. You just have to instantiate the view. You see here at the top, we create our header and our loader. And by default, when we construct a new one, they were given a new ID, and that's going to be stable for its lifetime. We do have to save them as fields. We can't, if we came here and we cleared models and said new header, new loader, that would have a new ID. And we'd be creating a new ID for header and footer every time data was set. So instead we save them as final fields, and then we know that ID is going to be the same for the rest of the adapter. Yep.
Can you have ID collisions for different types of objects? Or is it just very rare
Yeah, that can happen. So say that happens especially on screens like this where we have many item types coming from a database. We might have trips, places, homes, destinations, and these all have IDs. I built a little helper for this. I don't believe I merged it into the main Epoxy upstream fork yet, but internally it's what we're using. And I key it with a string. So I would say ID is, give it a string of homes and then home ID, destination string, and then just a kind of tag to namespace it. And I'm just using a hash function basically, like a 64-bit hash function to hash that string and then hash that long to it. And it maps it across the whole 64-bit space. So in that case, collisions are possible, but for hundreds of items, it's like you're just as likely to get hit by a meteor, so I'm not too worried about it. Unfortunately, the whole adapter crashes if there is a ID conflict. It just can't handle it. So if someone ever gets that unlucky, they're in trouble. But that's a hard problem to solve without extra work unless you really know what IDs you're dealing with. But in practice, it works fine. Good question, though. Did you have a question? No? Great.
This is an open source project too, so I'm sure you will welcome fixes.
Yeah, if you can think of a better way to handle IDs, please. And view state, we talked about this a little bit before. So RecyclerView, most views in Android framework will save their state. You have a text view, edit text, you input text, and rotate the phone. It'll restore that state automatically. But a RecyclerView can't really know how to do that because it doesn't know about what views you have, what view maps to what data. So it just doesn't try to even save state. Since we know that we have stable IDs, though, we can save state for you. So if you want to save a view state, you would just override this should save view state method and return true. That's all you have to do. And then what Epoxy does is when it unbinds a view, when you scroll off screen, it unbinds it. It manually calls save state on that view, keeps it in a map to the ID of that model. And when you scroll that view back on screen or rotate the adapter and restore state, recreate the activity, then when it binds that view again, it's going to look up any pre-existing state in that map for that ID, and if it exists, it'll just restore it. So not too complicated to implement, but if you need to do it yourself every time, just that extra overhead that introduces more chance of bugs and more code complexity. And with Epoxy, we can do it just one line, straightforward. Make sense? Saving view state in RecyclerView isn't too common, but when you need it, you really need it. And the diffing is the most interesting part to me. That's the part I spent most time kind of racking my brain about figuring out how to do. It's very algorithmic, very different from what I normally work on, so it's kind of exciting. And I originally built Epoxy back in like February or March, and we were using it for a while, and started out very basic with just binding views and unbinding. and evolved over time as we thought, hey, this feature would be cool. Let's save view state. Let's handle grids and span sizes. And I always thought it'd be cool to do data changes automatically too, but that's obviously much harder because you have to know when an item changed, and that's tricky to figure out. And we solved that by having each model implement hashCode. And so the photo model would implement hashCode and just hash the URL. So for a given ID, we have our photo ID, and if that URL changed, then we know we need to update the image view with that new URL. Pretty straightforward. For complex views, the hashCode implementation is not so easy, and that's, if you have to implement it manually, that's a lot of boilerplate that we're trying to avoid, so that's a problem. We ended up with an annotation processor to do that for us. And so basically with the diffing, we have a lot of cool algorithmic work going on in the background to take the list of all the models, go through it, check the IDs, and just by looking at IDs, we can know if you've inserted or removed things. The tricky part is checking for updates, and we compare hash codes on the models to check for updates. And it gets even tougher because we batch these. So we might know that item 1 was added, item 2 was added, and you have to look backwards and forwards to efficiently look at updates. Because if you insert 100 items, we don't want to call notify item added 100 times. It's not efficient. So we really want to be able to batch these. That's where a lot of the complexity comes from in the diffing. But once we got it working, it took me a while to get this working, and I had to write a lot of tests, but it works pretty nicely now. And it actually results in very nice performance. The diffing is very fast, and the drawing time is much faster than rebinding everything. For a view I'll show you in a minute, our listing details view, we were using a RecyclerView and just calling notify data set changed every time something, anytime we had an update. And it worked, but I replaced it with this diffing approach, and it went from having like a bunch of frames dropped every time we updated it to being in less than a frame, under 16 milliseconds. Unfortunately, right after I spent all this time writing our in-house diffing algorithm, Google released their diffutil and support library, so I was sad. Which does the same thing. Their diffutil is kind of built for RecyclerView. It takes item input, and you declare an ID and the state for each item, and it tells you what changed. Very similar. Different approaches. I built mine very explicitly for Epoxy. And because of that, I can actually take some shortcuts. So our diffing approach ends up being faster than diffutil, so I kept it. And we do a lot of shortcuts that diffutil can. So it might be good to use diffutil to reuse that code and not try to introduce new bugs because it's kind of complicated, but we wrote a lot of tests to make sure that it works well. And again, using this diffing just simplifies what your code looks like. So here, the diffing, what it looks like is you just call notify models changed, and that is its signal to go through and create a diff and notify the RecyclerView of item inserted, removed, etc. Otherwise, you're doing a lot of logic here. Check the previous loading Boolean, did it change, figuring out what position it was at. If you're adding more photos, you have to figure out what index you started at, what index you're going to. A lot of chance for off by one errors, classic problems. So the diffing is pretty cool. And like I mentioned before, it relies on hashCode implementations, which would normally be kind of a pain to write and maintain. Every time you add fields, you need to update the hashCode. So I built an annotation processor. So you annotate your fields with @epoxy attribute, and it generates a subclass, and it appends an underscore to every generated class. So if you have a photo model class, it's going to generate a photo model underscore. You saw that before up here, where you're using underscores after the header model and loader model photo, and that's the generated class. And that gives us the hashCode method for every field. It gives us a setter. So if we want to set title, set image, set description, we don't have to write those setters by hand. It'll generate them. they'll generate getters so we can access data off the model if we want to know what's on it. There's also some helper methods like reset if we want to clear a model and reuse it. There's a toString, and it'll duplicate whatever constructors are on your base model. So you can see here there's a constructor in this photo model, and the annotation processor will duplicate that constructor for us. So some nice things. And since I approached Epoxy with a mindset of reducing all of this boilerplate, the annotation processor seemed like really the way to go. Otherwise, we're adding more boilerplate again to get this diffing to work. And so we talked about the search use case. We have all these items coming from the server, or needing to combine them. But we can also use RecyclerViews for static content. This is our listing details page I mentioned before, and it's just taking Airbnb listing and showing all the details about it. And this is all content we know locally. We're not going to be paginating, adding more data or anything. So it could be done with just Android scroll view. Just define it all in XML. Be pretty easy. We don't have the problem of things scrolling off screen and not being able to access them. Pretty easy to write. But then you're inflating this giant view. You can see I had to put it on 2 pages because it's kind of long. We have this whole image at the top, and this is actually a carousel, so you can swipe photos inside here. This is a big bitmap we inflate to show the map, and this is another horizontal carousel down here to swipe through similar listings. Plus we have all these other little icons, rows and text in between. So between all the images and text, we're keeping a lot of data in memory. If we show this whole thing at once, we have to inflate all of this. Anytime the data changes, say we update the pricing or the dates or the guest count, we need to reload all this, and it gets a little bit excessive. So by using RecyclerView, we can load the layout faster. When the screen loads, we're only showing this much the first time, so we can just completely ignore the rest of the screen when we're loading it. We're using less memory. We don't have to keep the bitmap in memory, for example. We're also getting animations for free. Say we click read more. We have a translate button here that's not shown in the screenshot. And we want to translate this description. We can nicely show a loader animation, because whenever we insert something into this RecyclerView, the RecyclerView will automatically expand nicely for us. And finally, since we're using less memory and we have faster layouts, it means that the page loads faster. So when we're transitioning, it's going to be a little bit smoother. And we do a shared element transition here. I can show you what this looks like. Actually, I can't. Sorry, not on this device. So we normally do a shared element transition. It's disabled right now for my emulator. But we take that listing picture and we expand it nicely. And a shared element transition is fairly computationally intensive, but it looks really nice. So we want it as a good user experience, and it's a good smooth flow into this page. But if we're inflating this giant view, we're going to drop a lot of frames while we're doing that transition. The transition is going to be kind of choppy, slow. It's not a great experience. So it's really important for us to load this page quickly to avoid that. And the RecyclerView is the way to do that. I'm really over time, aren't I?
Is this fascinating though?
Yeah.
Sorry, should have noticed. Okay, so RecyclerView in a place you wouldn't normally expect it. Normally, with this many view types, we have probably 20 on this page. It would be a huge pain. Like, it just wouldn't be worth it because of the complexity. But with Epoxy, it actually looks very simple. And
So you divided each part of that page to a model?
yeah, are you guys interested in seeing the exact code, or are we out of time? No? It's okay.
Just a quick scroll through the exact code.
Yeah.
Sure. Yeah, I had just 2 more slides that were kind of talking about somewhat unrelated things, but
You've got the floor, so.
okay. Just real quickly, we have a design language system at Airbnb that we've been working on adding over the past year. And this just defines standard components, a marquee, an input row, a section header. And these live in their own view and live in their own library, and are independent of the data models that we have. So they just define like text or images, like simple components. And each view has a corresponding epoxy model that we can use in the RecyclerView. So say we want to create, our designer asks us to add a new page where we have a header, we're showing some listings, we're showing sections, loaders. We can take these pre-built DLS components, we already have models built for them, and we throw them into an adapter. And it allows us to build very quickly by reusing these components. And there's some overhead in originally creating the custom views and the epoxy models for each view. But once you have them built, and if you're reusing them across the app, it actually lets you iterate really quickly and build new screens by reusing components. And lastly, we open sourced this a few months ago in August because we found it really valuable for our team and we thought it would be useful for other teams as well. And I don't know if you guys are interested in open source work or have any experience with it, but it was kind of my first time open sourcing a library, and I learned a lot, and kind of sharing the benefits and pros and cons to it. Luckily, Airbnb gives me time to work on it and encourages me to do it and allocate part of my time to maintaining epoxy and dealing with pull requests and external issues. And we've been getting some good external contributors sending in PRs. Anyone's welcome to, and I look over all of them. And it's kind of fun in that regard, but it definitely takes time to look at these issues. We have to deal with documentation, making sure we announce all the changes we make. If we need a change just for our team, I can't just make it and push it out fast. I need to make sure I document it, make sure it doesn't break existing APIs. It adds some overhead there, but it's worth it to share with the community. Yeah, and that's it. Sorry, I went way longer than I expected.
This is great. Thank you very much.
Yeah, if there's any questions, please ask.